Hi, this is Ms. Carnicella with your calculus class, and I just want to go over a quick kind of a trick for integrating integrals that look like something like this. If you have an integral from negative a to a of f of x dx, there's some tricks on how to do these that can lessen the work. So we're talking about things that, if you notice right here, number is the same. We have a and a. So that's the first thing you look at to use this. So for instance, you might have something like from negative 7 to 7. Or you might have something like negative pi to pi. Or even like negative 3 pi halves over 3 pi halves. But the whole point is that you're going to have these same numbers, except for one's a negative and one's a positive. So when you see that, you want to question the symmetry. And you could do this by looking at the graph or doing the test where you plug in negative x instead of x into the function. Why do we do this? Well, we have these rules that say you don't have to bother doing all the work. If you know, for instance, if you know you have an even graph, and let's talk about that. If I have a graph that looks like this, this is horrible, hold on. All right, so I have a graph that looks like this. And when you look at this parabola, it's anything that you get on this side, you get on this side. So it's symmetric with the y-axis. And if it's symmetric with the y-axis, they'll call that y-axis symmetry, or they'll call it vertical symmetry. If you have vertical symmetry or y-axis symmetry, here's another example maybe. Oh, I shouldn't use the lines again. So I'll just give you another example. You might have something that goes like this. I'm trying to make them look exactly the same on each side so you understand. So let's make it look a little bit better, and I can't erase this right here, so just deal with that right here. And if each of these are the same distance, no matter on each side of this y-axis, then that would be vertical symmetry. And the rule of this kind of an integral, when it's vertical symmetry, is that if this is even, because this is considered an even function, if you really think about it, this looks like x squared. So it's even. If it's an even function, then you know that this thing, after you evaluate your numbers, no matter what they are, they're the same, and what the lower one is a negative, you're going to get, the answer will be really the integral from 0 to a of f of x dx times 2. And here's why. When you're doing the integral, you're trying to find the area under the curve. So here we're trying to find this area under the curve and this area under the curve, and they're going to be the same. So you know, just like here, this area under this curve is the same as this area under this curve. I don't know why I said curve. Okay, so since they're the same, whatever you get for an area here, let's just say you get 2 for your area here. That would be the same thing here. That would be the same area. So basically, you could just evaluate from here to here, find your area, and double it. And that's where you get the double. So that's even symmetry. And another way to test, instead of just looking at it, instead of just looking at the graph, you could actually evaluate f of negative x and see. If you can remember, the even function is when f of x is equal to f of negative x. And that's an even function. So all of this here is about even functions. So let's just say you didn't want to evaluate this. It takes a lot of time. If you know just this side, you know this side. Now there's another kind of function. So y-axis symmetry, we already just did that. Basically, let me just say one more thing about this y-axis symmetry. If I took just this part right here, and I put, let's say, a mirror, or I just said, okay, if I took this part and I flipped it around, it would end up looking just like this. That's where your symmetry is, okay? So now let's go through if f of x is equal to f of negative x, that's even. We know that. If f of negative x, if I plug it in, I get negative what f of x is, that's going to be odd. And let's talk about something like a function that looks like this. It goes through here, does a little thing, and it does the same thing almost. It goes through the origin on this side. I didn't draw it perfectly, but this is symmetry with the origin. If I was to take just this part here, I'm going to redraw this. 1 second. Let's just redraw it. So let's just make it, oh, I want it in black. Can I make those good? So basically, if I take this part right here, this part, and I rotate it in this direction, it wouldn't be this yet, but if I rotated it one more time in this direction, if I drew this on a paper and I just turn the paper around 180 degrees, I would get this part at the left side of the graph. So knowing this, if I look at this a different way, area of a curve, let's talk about the area, oops, the area from negative a to a of f of x dx. Well, here's negative a, here's a. I want to know what the area under this curve is, this whole curve. If I look at this, I said, okay, well, if the area under this curve here is this, whatever it is, and I find it by finding the integral, then I find the area here. You notice that the areas are going to be the same, except for one's going to be a negative and one's going to be a positive. So these areas here end up canceling out. So basically, if you know that you have an odd function, actually, and just remember that this is considered symmetry around the origin, or so I'll just say origin, but you could also call that rotational. When I was saying how you can rotate it, it's called rotational symmetry. That's an odd function. And what's that say? Well, if it's an odd function, you don't have to evaluate it. It's an odd function. So all you have to do is know that it's 0. So let me just take an example here. If I said to you, let's look at this. You have this. All right, and let's say you're here at -2 and at 2. And you've got this interesting graph that does this. For whatever this value is here, negative, positive of that gives you the same answer, and so on, and so on, and so on. Well, then that means that this must be an even function because it has symmetry about the y-axis. Now you can also have something that might have neither. Let's see if I can think of an example. Okay, you can have something that has neither. Let's say you have this squiggly line that just comes out like this. Well, no matter where I try, I can even go like here. I would get this and this, but I'll never land with anything else on top of it. So there's no symmetry here, so it's neither. So you would put neither for that. Now, just to show you what a quick example. Let's just say you have this crazy looking thing. Okay, so right there, negative pi halves to pi halves, sine squared x dx. all over 1 plus x to the 6th dx. So since the range looks like it's from negative a to a, it's time to consider checking if it's odd or even. Now, in this case, I don't have the graph. I could go to Desmos and graph it and see if it looks odd or even. So I'm going to say, okay, well, if I put, if the f of x is equal to sine squared x dx over 1 plus x to the 6th, I'm sorry, this should be dx over here. It means the same, but it looks better right here. No, there is no dx. We're just going to do the function, not the dx. And then I plug in negative f of x, or negative x into f of x. So that would equal sine squared of negative x all over 1 plus negative x to the 6th. Now, know that the sine squared of negative x, oops, and I forgot the x squared. No, that's fine. Okay, so is equal to negative sine x. Then I have 1 plus, well, negative x to the 6th, that's an even power. That's just going to equal the positive x to the 6th. So if you notice, this was my f of x. And here is the f of x, the same f of x. So this negative here tells me that I have an odd function. And because of that, now I know it's odd. I don't have to do any work. I don't have to find the derivative, plug in negative pi halves, plug in pi halves. I know it's odd, so I know right away my answer is 0. That's how we use symmetry on graphs. If you have any questions, please reach out to your teacher. Be great.